vertical versus straight cubical wave. Geometry. So there's a saying in software industry saying if you fail to plan, plan is bound to fail. Golden rule. So if you don't pay attention to the fundamentals, basics, you will definitely fail. So today we'll start from scratch. Let us take a line segment of magnitude 2r. R is radius, of course. Let us build these geometries from scratch. In my book and in my last video, I already told you that the integration of curved surfaces, the curved surfaces can be built using integration, whereas straight surfaces, simple multiplication will do. Right? So let us take this. Let us start from pi, which is 27. This is connected. It connects spherical to cubical and cubical to spherical. Meaning, this is the correlation pi. So let us integrate pi with respect to r. What you get? Uh, um, if you're yeah, pi r. And if you take two such pi r's, integrate, you will get pi r square, right? Pi r square, 2 into pi r square by 2. So they get cancelled, pi r square remains. So this is equivalent to here only. Let us also take the uh, line segments here also having same magnitude r, right? Uh, we already got the circumference, that is 2 pi r. This is pi r square. Here we have line segment, we have 4, uh, this will be like, let us say, we take square around this is r, this is r, so this will be 2r, so we just should also be 2r, right? And so because we are taking ascribing um, square, not inscribed square. So ascribed square will have 2r as the length. So 4 into 2r equal to 8r. That is, where was that? Yeah, yeah, this is, uh, let us take 2 pi, 2 pi and 2 pi r. We will get this is circumference of circle. This is area of circle. This is basically circumference of uh, square. Let us keep it here because this is area. This the circumference. This is area of square, which is nothing but comparable thing is nothing but 2r into 2r. That is 4r square. Right? So if you compare these two, 2 pi r, 8r, right? This 2 pi r is equivalent to 8r here, 2r 4 times. So 4 times r cancel, 22 by 7, 4, 11, here 2 is because if you take multiply this by whole both sides by 7, then you will get 11 is to 14. This is the ratio 11 is to 14 for the circumference. Now we'll do the same thing for area. Area is pi r squared. Here area is 4r squared. R squared we can cancel. 22 by 7. What was that? 4. Yeah, 4 is 4 here. 11 to 11 is to 14. So 11 is to 14 is the ratio of a circle and square, the circumference and the area of circle and square. Square, I mean, in the sense straight surface, cubic surface. Uh, Ultimately, we will go to sphere, right? So this is spherical, this is cubical. Let's say spherical, cubical. So if you take the ratios, or ratio of the circumference of circle to that of the circumference of cube, then you will get 11 is to 14. If you take the area of the circle and area of the square, which is four square, uh, you will get still you will get 11 is to 14. Let us go ahead and integrate 4 pi r square. Let us take 4 pi r such pi r squares dr equal to 4 pi into r cubed by 3, which is nothing but the volume of sphere. On the following the same logic here, I mean comparing with a similar object, volume of cube. This will be right. Volume of cube. What is a volume of cube? Uh, 2r, 2r, whole cube, which is 8r cube. If you compare these two, again, what will happen? 4 pi r cube by 3, 8 r cube, r cube by 2, 2 times 22 by 7, this is 6, 11, 3. So this will be 11 is to 21. So if you compare, now we are taking the whole sphere. the whole sphere we took and whole cube. If you compare volumes of these two, you will get 11:2. Okay, so I hope you are with me. Now we will integrate again. Here we took 2 pi, here we took 4 pi. So logically, what should we take next? There are two ways. Either you go with 2, 4, 6 series or 2, 4, 8. You either multiply by 2 or you take a difference of 2, add 2, add 2 plus 2 plus 2 into 2 into 2. You will take, if you follow this method, then what we will get? 6 pi. 6 pi into 4/3 pi r cube dr will yield 6 pi in, 6 pi 4/3 is, this will cancel twice, and 8 pi r cube, 8 pi r raised to 4 by 4 meaning 2, this is 2 pi r 4, 2 pi r 4. What was this here? We began with 2 pi r and we at the fourth level, let's say this is the first, second, volume third, this is fourth time integrated, we got 2 pi r 4. We started with 2 pi r, we ended up with 2 pi r 4. What does it mean? This is nothing but 2 pi r square whole square, isn't it? As if the radius is square. So just now let us see on this side what will happen. What should we take? Well, this should be 6. We will take the surface area. Surface area of this will be, we have taken volume, we haven't taken surface. Yeah, this was the, no, this is now, this this is volume, of course. We missed one thing here, I think, here of area of square. Area of um, surface area of cube is 6 times the side. Side is 2r, so 12r. That was that we missed. Okay. Yeah. Anyway, that's fine. So volume we took. If we took 6 spheres here, 6 spheres, volume of 6 spheres here, we got 2 pi r4. This is basically 2 pi r. So, 4 into r. This is the first one, comparable to circumference. Second one is comparable to area, and then third one is comparable to volume. The fourth one will be, let's say, 2r whole raised to 4. That is um, 16 or 4. Meaning, this will be like cubes followed, cubes consequent subsequent cubes. Like these cubes will be going on for how many, uh, 4 times this, if you take 4 times this cube, that will be 4 into 4 into 4 into 4. 4 into 4 cubes, meaning 2 rows of this. If you take, that will be the equivalent term. But let's not bother about that. Basically, what I want to tell you is at the fourth level, yeah, what I wanted to tell was this cube will become a line basically. Each is cube. This will be line of cubes. So just remember this fourth level was repeating. Fourth level, we began with a line here. It became a line of cubes. We began with 2 pi r here. It became 2 pi r 4, meaning the fourth dimension. This will be more like, actually, the other one will be more like tesseract. It will be more like tesseract. 16. Now, when I said um sphere part geometries we have covered from scratch to the fourth dimension. Now, we will see how it is relevant in the context of, let's say, light. Okay, so the light is 3 into 10 raised to 8. Here, I am not talking about anything else other than dimensions. I mean, the magnitude. Okay, not direction. I'm not talking about direction. I'm not talking about vectors right now because um, we have to follow the suitable mathematical tool to do this. So 10 square, 10 square, 10 raised to 4 if you take, and you take uh, normal, this will become 10 raised to 6. Okay, let us not connect these two right now. Let us first basically take 10 square, the basic quantity, which I call this my string. This is my string. Take 10 square. I will explain later why I assume so. This is my string. 10 square. We start from here, the basic fundamental core entity. And this 10 square, we 10 square, 10 squared. If you take cross product of 10 square and 10 square, you will get 10 raised to 4. If you take cross product of 2 and 10 raised to 2 and 10 raised to 4, you will get 10 raised to 6. Because what is the cross product? Cross product formula, cross product is A into B sin theta. As long as this angle is 90, you can get this vector, this direction will be this way, right? And the magnitude will be given by parallelogram. So here we took 10 square into 10 raised to 4, 10 raised to 6. theta being 90, so let us say 790 itself. So 10 raised to 6 we got. You take another 2 here. This is yeah, the upper particular to this. Let us take the 10 raised to here. These are independent. Don't mix this with this. This is 10 raised to 6, and there is 10 raised to 2 again, 10 raised to 2 again here. This 10 raised to 2 is 10 raised to 2, and again you have the same. You will have 10 raised to 8. What all I mean is, you go on building this 10 raised to 8. Before building that, if this is this side, this is the surface area, this is the volume, and if you take 10 raised to 6 and 10 raised to 2 again, the product, then it will be yield 10 raised to 8. So the thing is, what I mean to say is, to arrive at this 10 raised to 8 is nothing but this being volume, this being the what we arrive at as 2 pi r 4. Okay, so this 2 pi r 4 is like the fourth dimension. This is the first dimension, second dimension, third dimension. This is the fourth dimension. Similarly, on this side, we will have what we take 10 square. You take 10 square, 10 square. This will become 10 raised to 4. 10 raised to 4 into 10 square. Let's say, I mean, if you take cube of it, 10 square, let's say, will compare, right? 10 square, 10 square, 10 squared is 10 raised to 4, and 10 square cubed is 10 raised to 6. This cube is nothing but this 6 volume, 4 third by r cube, and this is r cube, 4 third by r cube, and then we have this 3 into 10 raised to 8. It is nothing but a row of cubes. So this is a 10 raised to 10 raised to how much? 10 raised to 6, 10 raised to 6 whole square. Okay, 10 raised to 1. You will do this way. So if you extend this to higher, 10 square, 10 raised to 4, 10 raised to 6, this is integration, I mean, what do you call cross product, and this is just a kind of multiplication. This 10 raised to 4, 10 raised to 4, 10 raised to 10 square, 10 4, 10 raised to 6, and 10 raised to 8. When you take the cross product of this again with 10 raised to 2, you will get 10 raised to 8.